This is a Bomem DA-3 Fourier transform infrared spectrometer. And this is a PDP-1173 with a high-performance vector processor. These two things are supposed to talk to each other, and they currently don't. So let's make them do. Let's make them do? What kind of English is that? We've spent the last couple of episodes diving in deep on this Bomem DA-3, and if you're curious about what a spectrometer is and how spectroscopy works in general, I highly suggest going and checking out those episodes. I dive into a whole lot more detail on the concept of spectroscopy. So in this episode, what I really want to do is I want to get this plugged into the PDP-1173 so we can take control of it from the PDP and start getting interferograms out and start building spectra of things. Now, this DA-3 has a full-fledged computer in it here, and actually the main processor board, which is this one right here, is based on an 8085. So this thing has a whole lot of smarts in it, but it does need something to control it. And there's a massive plug on the top, a 50-pin D-shell connector that's going to go over to the PDP-1173, but therein lies some difficulty. The PDP-11 has a pretty bog standard 1173 CPU in it, and that's it as far as standard cards go. Everything after that is either third party or completely custom. We have a QRAM 44B memory card with 2 megabytes of memory on it. We have a Sigma floppy disk controller for the 8-inch floppy drive. We have a Webster SRQ-D11 for the 5¼ MFM drive. Then we have a Matrox QRGB card that is paired with a Bomem-made DEB41. These two together allow us to put full color graphics as well as ASCII text on the same monitor. So we can get this really cool screen that shows the spectra of whatever it is that we just checked with the spectrometer. Then we also have the DEB18 over here. This is a card specifically for talking to the high-performance vector processor. And this vector processor add-on turns the PDP-11 essentially into a very compact supercomputer. It has an AM29116 16-bit bit slice processor in it, 2 massive WATEC register files, and these 2 little chips right here, even though they're not marked, I'm pretty sure are WTL 1032 and 1033s. It's going to be a hardware multiplier and a hardware adder. And there's a boatload of high-speed static RAM in this thing that the microcode is loaded into to do its multiple instruction, multiple data, vector math, and knock out fast Fourier transforms in under half a second. Now, I have done a couple of FFT calculations using this, but I've only done them on interferograms that were already stored on the hard drive. I wanted to take a new interferogram using the Bomem DA-3, send it over to this high-performance vector processor, do a fast Fourier transform on it, and see the spectra that's coming out of it. And we're going to use this little board right here to do that. This is an opto-isolator board that allows us to connect the high-performance vector processor to the DA-3. We do need to supply separate power to this. I think it's only going to take 5 volts, but I need to double check the documentation on that. And we have an extra little connector up here to go to a serial port. And then I got to find someplace to mount this thing. When I built this case that's holding the PDP-1173 and the high-performance vector processor, I didn't have the Bomem DA-3 at that time, so we were just kind of building it to be standalone, and I didn't really plan for putting this in there, so there's not really any good place to put this, but I think I'm going to tear this completely down and rebuild it properly into a desk like it's supposed to be. But we're going to do that when some other exciting stuff shows up in a couple of months. So for the time being, we're just going to do something a little temporary to get this plugged up so we can start making sure that everything works. I'm going to need to make a 50-pin ribbon cable for the vector processor, a 10-pin ribbon cable for the serial, and some cables for the power. Looking in the manual, it seems this thing needs plus 5 volt as well as plus and minus 12 volts. My PDP-11 only has plus 5, plus 12, and minus 5, so I'm going to need to add another 12-volt supply for negative 12 volts. This is a little wall wart that I built into a box, so I'll bend up some tabs and screw them into the box, and then I'll bolt the whole thing to the back side of the card cage. To mount the opto-isolator itself, I'm just going to temporarily bolt it to the side. I'll screw down a little bracket that'll hold the bottom of the opto-isolator board. Then I'll mount a small chunk of wood further up that'll give structure to the top. 2 screws in the bottom to hold the opto-isolator in place, then a little tab up top, and that should get the job done for now. Next, I'll start soldering up the power wires. I need to get mains AC up to the wall wart box and make sure that all the grounds are in the right place for negative voltage. Then I'll run the ribbon cables, starting with the 50-pin cable that has to pass through the box for the vector processor. The smaller 10-pin cable I'll cut down to just 5 wires for send, receive, and 3 grounds. I'll then snake that into place and get it plugged into the DEB41. Finally, before powering up the opto-isolator board, I'll double check that all my voltages look good and are in the right places, and yep, I think we're good to go. Let's plug in that 50-pin cable to connect the Bomem and oh, that's not a good sign. They're both male. I'm going to need a gender changer. $50 later and here we go, but really, I shouldn't need this at all. Something is not right here. Still, let's soldier on and find out what is not right. The cable was a bit heavy, so I put a bit of string on it to support it, and this is super jank, but remember, it's really only temporary. This is the first time I've had that Bomem DA-3 hooked up to this PDP-1173. I have no idea if anything is gonna work at all. I don't know, we'll give it a shot. So I'll go ahead and type menu here at the prompt in the 1173 here. It's gonna boot up the Bomem DA-3 Spectrophotometer software. And we're fully in here. There's a ton of options to do, but I think the first one we'll do is we'll just go to status here. So I'll do an STAT. This should communicate with the vector processor and hopefully the DA3 over there. It says loading microcode up here. I can't see, nope, there it goes. I mean, I don't know what I was expecting it to tell me. I've been in this menu before and it looked all the same. All the analog channels were at 0. The digital channel was at 0. I don't know. Let's just fool around, see if we can get it to do something. All right, we'll do a Control Z to get out of that. Let's do a phase, okay. I don't know what any of this means. I am well out of my depth here. Let's just hit return and see what happens. It says task already active. The spectrometer didn't do anything. I don't know what I'm doing. I think this is gonna take maybe a couple of phone calls and a lot of reading. And I'll get back to you guys once I have a clue what's going on here. All right, I had a little call with Mike and we did some experimenting. The PDP-11 software is kind of obtuse and nobody's used it for like 20 years, so it's taking a little bit of learning. But it seems that we have decent communication between the PDP-1173 and the high performance vector processor. However, we don't have any communication between the high performance vector processor and the Bomem here. So we've got a couple of things that we're slightly worried about. One is the gender changer on the cable. That absolutely should not have been necessary. The next is that there's serial communication between the PDP-1173 and the opto-isolator board. I've got RX and TX set up on that, but I could have that backwards, which would prevent any serial communication from making its way over to here. However, the bigger problem that we think we have is that right up here is the opto-isolator board for the Bomem itself. It seems that this is the upgraded opto-isolator board, which has a little power plug right on the front here. And that power plug is not plugged in, which means no communication ever makes it past here. Looking back at my previous footage, we had a 5-volt 6-amp power supply go bad. This supplied 5 volts to the computer, but also there was a long cable soldered to it that I had no clue where it went. Well, now I know. It was power for the communication board up top. Let's pop this board off so I can find a part number on it. It's held in place with just 4 screws, and then we can see that this is the IEL61 revision. And looking at the schematic for this board, it just needs plus 5 volts and ground. Easy peasy. Now, I threw away the old cable because it was in pretty rough shape, so let's make a new cable. I'll measure out and cut some new wires, then clamp one end in the vise and the other in the drill, and just like that, nice and neat twisted power wires. Next, I'll strip and add connectors, and later I added in a plug to make removal a little easier, but I was too impatient to do that just now. I'll plug it into the communication board up top, then spend some time routing it neatly along the back, and down to the power supply below. Since we replaced the PSU that was originally meant for this, I'll just screw these into the replacement meanwell supply that's in there. All right, things have gone horribly sideways because Of course they would. Why would anything go smoothly in this room? I didn't catch it on camera because I'm a big dum-dum, and I'm not going to do it again because I'm afraid it's going to break something. So you'll just have to, my words will just have to paint a picture for you here. After putting power into that opto-isolator board up there, we flipped the power switch on the Bomem here with the 50-pin cable disconnected just to make sure that everything was copacetic, and the Bomem comes up totally fine, goes into mode 4, finishes its boot up sequence, ready to go. However, if I turn the Bomem off, plug in the 50-pin cable, and turn the Bomem back on with the PDP-1173 off, the Bomem freaks out. It goes to mode 2 immediately, and it starts power cycling. Like the front panel starts flickering on and off. I can hear relays kicking off, the lasers turning on and off, and it's doing it at random intervals. So my first thought was maybe it's a power sequencing thing. So I turned the Bomem off, I turned the PDP-1173 on, got it fully powered up, and then turned the Bomem on, but same story. Straight into mode 2, power cycling like crazy and random intervals. Really unhealthy stuff and kind of terrifying. And so what's going on here is that our two opto-isolator boards are different, wrong revisions. Now, keep in mind that this Bomem is incredibly powerful and it's been used throughout several decades, but the computers often got upgraded. So I think what's going on is I've got an opto-isolator board for a newer system than a PDP-1173. And we dug through the schematics. We don't have schematics for any PDP-11 related stuff, but we do have schematics for almost everything related to the Bomem DA-3 itself. And I came up with this list right here. There are 3 different revisions of opto-isolator boards for the Bomem, but they all have incredibly different wiring. We have a revision problem going on here. We need the IEL-27 opto-isolator board in the Bomem, and we've got the IEL-61. So how do we fix this? Well, the appropriate thing to do would be to wait and see if Mike has an IEL-27 in his stash, but Mike is not sure that he does because nobody's used a PDP-11 on a Bomem for like 30 years. He's also not home right now. He's out on vacation. I don't want to like break into his house, and I want to enjoy his vacation. So let's think about what other options we have here. And well, Mike said that he has a bunch of these 50-pin cables at home. He's got 5, 6 of these, and they're just straight through cables. So what I could do is I could take one of these apart and maybe slice the wires and create a custom 50-pin crossover cable that connects the IEL-61 to the PDP-11 here, which is expecting an IEL-27. Most of the signals all look the same, and I think I can create a list that tells me what goes where. It's tedious, but I wanted to give it a shot. However, my return paths are a bit of a mess. The cable is made up of 25 twisted pairs, and those are connected with the appropriate return paths for the IEL-61. I'll need to essentially remake the cable from scratch if I want to get all the return paths lined up correctly. But let's start with just getting basic communication happening. If we discover later that we need to sort the return paths better, we'll deal with that at that time. All right, I think I've got that cable wired correctly now. It's a bit of a mess, and if it doesn't work, it wouldn't really be all that surprising, but I don't know, let's give it a shot. Right now, it is plugged into the Bomem and the PDP-11. The PDP-11 is not on, but it is plugged into the wall. So what we want to see is this thing come up and not do anything crazy, hopefully. All right, so I'm going to do the switch with my foot here so I can keep an eye on things. And power coming up. Yeah, so we're in mode 4. That's already a huge improvement over what it was before. So I think our next step is to turn the PDP-11 on and see if it doesn't go crazy again. Okay, the PDP-11 is still not on. All I did was plug in the monitor. It's going kind of crazy. There it goes. You can see it. It's going crazy again. The monitor is on. If I can turn it off, but that didn't seem to make a difference. It did it once before with the monitor. What is going on? Yeah, there it goes. I'm not crazy. I'm not crazy. It did it once there. Let me unplug the monitor from the outlet. Let me unplug the PDP-11 from the outlet. I have no idea. I have no idea. Whenever I have a problem that just doesn't make any sense, it's always grounding. And usually it's because I don't have enough grounding because I'm lazy. But in this instance, it's not that we don't have enough, it's that we have the wrong grounding. If we look at the schematic, the 5 volt that we're supplying to the opto-isolator board is actually an isolated supply. It's marked as plus 5V ISO and GND ISO. And right now I've just got it tapped off of this little bean well down here because that's where they did it originally. I can't tap off of that, and I have no idea why they were able to tap off of the equivalent linear supply on the original version of this, but like we can't do that here. Maybe they were plugging it into a more modern system so they were able to get away with one or something like that. But I've got a spare mean well here. I'm going to try and slip this in there, hook the line and neutral up to it, and then have this be the supply for everything else, and then that smaller one be the supply for just the opto-isolator. So that way it's fully isolated. But that means I gotta get this whole power supply unit out, which is a giant pain. To get the power supply out, I'll disconnect 2 connectors on the right side, then 2 more connectors in the middle, and 4 more connectors over on the left side. Fortunately, I've done this so many times, everything comes undone pretty easily. Then there are like, I don't know, 12 screws around the periphery, and with those removed, the whole thing comes out. Over on the bench, I'm thinking I'll slip the extra 5 volt supply in like this. Now, I can already hear the furious typing of keyboard engineers already. Using a modern switch mode in this part of the machine is totally fine. Heck, the new one we're putting in is specifically for talking with the PDP-11, which is running on pure mean wells already. And originally, the PDP-11 was powered by a Power 1 switch mode from the 80s. So, you know, chill on the switch mode hate. Okay, spectrometer's on and powered up. Isolated power supply seems to be doing just fine. Looks like we're in mode 4. Hasn't power cycled once, and everything's plugged in, just nothing's on at the moment. Let's turn the CRT on, because that was, in my testing, that seemed to be when things got the most crazy. So whenever I kick the CRT on, this thing would power cycle. That's a good start. It didn't power cycle. Let's turn the PDP-11 on. There we go. All right. Let's get into the software and see if we can make it do something. All right, we're fully booted back up. Let's go ahead and log in. So I'll do hello Usagi. The password is Usagi if somebody wants to break into my PDP-1173 here. And then we're gonna go ahead and type menu to load into the Bomem software. The Bomem itself is still sitting in mode 4. I would expect it to change modes here momentarily, hopefully. Let's just start with a phase. Let's just do a PHAS. Let's go ahead and hit a return on this. It says it's loading microcode, VP error 101 on send command. That's not good. All right, if I check the manual, it says that error 101 is a failure to load microcode, which indicates a communication problem between the DEB-18 and the vector processor. So it's something before we even get to the spectrometer. And so like that was working before. And so I just shut it down. I double checked all the cables. So let's do something that's not involving the Bomem at all. So let's do a complex fast Fourier transform. So we're just gonna do a comp here. And we're just going to use the reference interferogram here. So I'm just going to hit enter on this. And yeah, wait loading microcode. So like it clearly is communicating with the vector processor. So it can load microcode. Actually, it's loading a boatload of microcode right now. There we go. Transferring data from host to VP, computing FFT, transferring data from VP to host. And yeah. There we go. All right, so that should definitively prove that we are able to communicate with the vector processor successfully. So let's try phase again. And we're gonna load this one up. All right, let's just try this one more time. We'll see if it'll load the microcode in. VP error -6 on send command. If I go into the manual here, let's see, -6 says timeout communication problem with the interferometer. check the cabling between the DEB41 and the HPVP. All right, maybe I've got receive and transmit backwards yet again. I think what I'll do is I'll shut it all down and I'll swap those back around to the way they were and we'll give it another try. All right, I keep going on about serial communication, and that's because even though we have that massive 50-pin cable that's connecting the spectrometer to the PDP-11, the bulk of that is just the ADC value coming back. There's a little extra information like ZPD and things like that, but most of the control and communication going on between the two is happening via RS-232 serial. The RS-232 that's coming out of the PDP-11 is coming into the opto-isolator board and going into an IC that is an MC145406. This is an RS-232 driver receiver chip. The signal is coming into pin 2, so if I put my probe on pin 2 right here, you can see that we're sitting down at around about -4 volts. So I'll go ahead and hit single shot on that. We'll run a phase, and yeah, you can see a flurry of RS-232 data coming into this IC. Goes from about -4 up to about 10 volts. And then the output on that IC is on pin 15. So if I put my probe on pin 15 here, that does not look good. Oh, now it went fine. But it was dancing. Oh, there it goes. It's dancing around a little bit. Let's try to get a scope shot on that. So I'll do a single, and then we'll run the phase again here. And yeah, okay, we got some serial data out, but boy howdy does that not look good. I mucked around with it a little bit more off camera, and once I got the scope probe cleanly through the oxidation layer on pin 15 here, the signal came through clean. So the RS-232 driver receiver chip there, I think, is working totally fine. Now there's a couple of things after that. There's a buffer and then a PNP transistor to transmit it down the cable over to the Bomem, and those could be bad, but I started thinking about this. I had a tremendous amount of trouble getting the RX and TX correct from the PDP-11 to the opto-isolator here. It like literally took me like 2 hours today to do it, because every time I took it apart and put it back together, I somehow got it backwards. Like, I've been doing this for 5 years and I still get it wrong all the time, multiple times. Like, how can I be so bad at that? But I started looking it up, and I went back through my notes to see, did I get the RX and TX on the data cable correct? In my notes, I saw that I connected up pin 46 to pin 49, pin 45 to pin 50. This should be our transmit going into the Bomem. And looking at the schematic, that is wrong. We have the transmit coming from the Bomem and the transmit coming from the PDP-11 running into each other. So it's just been like a comedy of errors of me just getting RX and TX backwards over and over and over again. All right, back in the menu program here. I'm not confident because I think that thing should be changing modes the moment that we get into the menu program here. But I don't know, let's give it another shot. We'll do PHAS here for phase. It's gonna load up a bunch of stuff. We'll go ahead and just tell it to run that. It's gonna load a bunch of microcode. And as soon as it gets done loading the microcode, it should fire off a serial signal over to the Bomem. Hopefully down the right wires. Nope. Same VP error, -6 on send command. Oh man. To summarize this video so far, the Bomem DA-3 was set up for talking to a Windows XP machine, and I've been trying to force it to talk to a PDP-11, and it has not been going well. You know, there's the fundamental problem that we have opto-isolators on both sides, which is totally unnecessary. And if we had the proper setup, it would actually be a current source board in the Bomem and opto-isolators on the PDP-11. But I think I figured out what the problem is, and it comes down to one extra inversion of the RS-232 that's going between the two. So if we had the proper setup, we would have the IEL-27 in the Bomem to talk to the opto-isolator board in the PDP-11. And so if the PDP-11 is sending some RS-232 data to the Bomem, it's going to go as RS-232 out of the DEB41 into an MC145406 that level shifts this to 0 volt to 5 volt TTL. It also inverts it in the process. Then a 74LS125 buffers it up and sends it into a PNP current driver, which inverts it one more time, sends that down the 50-pin ribbon cable, goes into an HCPL2630 opto-isolator and the IEL27, which inverts it yet again. Then that gets fed into an MC145406, which then level shifts the opto-isolator 0 to 5 volt output to RS-232 levels, inverts it, and sends it on down to the Bomem. And those multiple inversions end up with the same signal coming out. But we have an incorrect setup here with an IEL61. So if the PDP-11 is sending serial data to the Bomem, we start off just the same. DEB41's outputting RS-232 through an MC145406 to level shift it, which inverts it, then the LS125 to buffer it, then a PNP current driver that inverts it and drives it down the 50-pin cable. Here's where things get weird. The 75176 bus transceiver takes the differential input and turns it into a TTL level output that gets fed into an HCPL2200 opto-isolator. But because of the way that they're feeding this opto-isolator, you end up with an inverted signal coming out the other side of it. And then they have a 7404 that inverts that opto-isolator output signal, and that gets fed into a MAX 233 that level shifts it to RS-232, but the MAX 233 inverts it yet again. And so the RS-232 levels going into the Bomem are perfectly inverted from what the PDP-11 is sending to it. Now, I haven't gone through and checked, but it's entirely possible that all of the ADC signals and everything else that's going through this entire chain is also going to have this same inversion problem. And it may just end up being that everything is backwards between the two. Where do we go from here? How do we fix this? Mike is pretty sure, I've been talking to him on the phone throughout this, he's pretty sure that he has the correct IEL27 that goes up there, and so we can swap that in and actually have proper real deal communication going on between the two. And I'm gonna drive down on Monday or Tuesday, weather permitting. The snowstorm showing up this week may put the damper on those plans, but I'm hoping to get down to Austin, get the right parts, come back up here with the correct IEL27 and the correct 50-pin cable to connect the two, and then we should just be off to the races. But if Mike doesn't have an IEL27 or the correct cable, we're not totally dead in the water, because I have the full schematics for the IEL27, and it's mostly just Zener diodes and PNP current drivers. So I could totally design out one of those and build a new current driver for this, get it plugged in, and do our proper communication that way. I mean, I would have to do some cable modifications to make sure that all the twisted pairs are in the correct places, but I think that's pretty doable. So we're gonna call it here in this episode. I really thought that we could engineer our way out of it. We might still be able to if push comes to shove, but by far the better solution is to run down and get the real deal proper parts. So we're gonna get into that next week, hopefully, and I hope you guys come back along for that ride, because then we're gonna actually talk to the PDP-11 and do some real deal science. So I wanna thank you all so much for hanging out today, and I hope to see you in the next one.